Welcome back. We'll look now at our first conic section. We'll discuss circles. One way to think of circles are sets of points that have a fixed distance to some center point. The point at which we are a fixed distance from is typically called the center. And the distance itself is typically called the radius. So to write the equation for a circle, I should give you two pieces of information. I should give you what the center is, that is, what point am I a fixed distance from, and I should also tell you what that distance is. I should tell you the radius. So what does the general formula for a circle look like? Well, it looks something like the following. I'll write it as x minus a squared plus y minus b squared equals r squared. Let's interpret this. So we'll say that AB is the radius. I'm sorry, that is the center. And we'll say that R is the radius. So our points x and y are a fixed distance r from the center. So just to get an example, let's plot x minus 1 squared plus y minus 1 squared equals 4. So in this case, the center is 1, 1, and the radius is square root of 4, so 2. So our picture is something like the following. I'll draw a little Cartesian grid. So here's the y-axis and here's the x-axis. My center is at 1, 1. And now I'll draw the set of points that are all distance 2 from the center. So here, 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 here. So something like this. So this is how you want to interpret the formula for a circle. You want to understand what the center is and also what the radius is. So what kinds of geometric quantities can we measure with a circle? Well, we can measure the distance around it, which we call the circumference, and we can measure the space inside of it, which is called the area. So these concepts might already be familiar with you, but I'll review them briefly. So we'll call the area formula for a circle is simply pi times the radius squared. So I compute the radius, square it, and then multiply by pi. The circumference, which is the area around the circle, or the length around the circle, is 2 pi times the radius. So in this example, let's compute the area and the radius. The area and the circumference. The area is pi r squared, so pi times 4, which typically is written as 4 pi. It just looks nicer to put the integer in front of the pi. And the circumference is equal to 2 pi times the radius, so 2 pi times 2, which is also 4 pi. So this is one of those very rare cases in which the circumference is equal to the area. The circumference can also be written as simply pi times d, where d is equal to the diameter of the circle. What is the diameter? It's simply the length across the circle. Which is generally equal to 2 times the radius. So in this picture here, we can illustrate the radius as a line from the center to the edge, and then the diameter is a line from the edge through the center and then back to the other side. So that would be the diameter d. One concept that's particularly nice with circles is computing a piece of the arc, a length along the edge of the circle, based on the angle that cuts out that arc. So the picture you want to have in mind is the following. If I have some circle, the known center, and a known radius, I can consider the following problem. I can look at cutting out an arc with a corresponding angle theta and try to ask, what is the length of this arc? So how can I compute that? Well, thankfully, a simple proportion problem will solve this. We can show that the length of the arc divided by the circumference is equal to theta divided by 360. So this tells me that if I know the angle theta and I know the total circumference, I can compute the length of the arc just simply by following this formula. But suppose I was only given the radius and not the circumference. Well, I know how to compute the circumference from the radius, so this is no problem. Just recalling that the circumference is 2 pi times the radius. So this is a very simple problem, but one that the CLEP exam might ask you just to test your idea or the knowledge of circles. So let's look at an example. Suppose I have a radius of 5 and a circular arc with theta equals 90 degrees. So the picture is something like the following. And I want to know this length L here of the circular arc. How can I compute that? Well, I could try a lot of different things, or I could remember that all that matters is the ratio of this angle which cuts out the arc to the total number of angles of 360 degrees. So I can follow this and say that L divided by the circumference, 2 pi times r, is equal to 90 divided by 360. So L divided by 2 pi times 5 equals 1/4. So L equals, this is 10 pi over 4, which I could perhaps simplify as 5 pi over 2. And it would be typical to leave it like that. Since these types of questions you will typically not have a calculator for, so you'll not be asked to do a decimal expansion of this. So let's make a quick review. Circles are a type of conic section. They come from the case in which our double-sided cone is intersected with a plane in a particularly simple way. The plane simply cuts perpendicularly one of the cones, and this yields a circle. What kinds of properties did we study? Well, we understood that circles could be described via their center and their radius. And we looked at a formula that encapsulates these two properties. So this is the connection of analytic geometry. It says I can study a geometric object simply by writing out an equation. We discussed notions of area, circumference in terms of the radius, practiced drawing pictures, and we also looked at the problem of computing arc lengths given an angle that describes that arc. With these techniques, you should feel well prepared to begin your study of conic sections. Continue to read from our book and continue to work on our exercises to master this material.